Math 2414, area between curves. Area between curves, example 2, unknown interval. In the previous video, I kind of ended with a subtly evil laugh after saying what could possibly go wrong. And this really isn't something that's wrong. It's more like something that's different and a little inconvenient at times, not always inconvenient. But maybe you won't be told the interval over which to integrate. Find the area between the graphs of y equals x squared and y equals negative x squared plus 2x, which is equivalent to saying find the area of the lamina bounded by those graphs. So we need to find that lamina and set up and evaluate the integral to calculate the area between them. So let's graph these guys. And by the way, there's no shame in using a graphing utility to facilitate getting the graphs. In this day and age of technology, technology can pretty much do everything that we ask it to, if you know how to ask it and if you have the right device. I'm not teaching you how to use technology. I'm teaching you how to think so that you can adapt when things change in new scenarios and new settings. All a machine can do is what somebody tells it to do. But what if you run across a situation that nobody's told it how to do yet? That's where man beats machine. So yeah, could we get something to do this? Absolutely. Am I going to? Absolutely not. But that aside, do not be afraid to use a graphing utility like desmos.com, D-E-S-M-O-S.com, to help you with the graphs, but I implore you to try to sketch all the graphs manually first, then use the technology to confirm that what you did was correct, and if what you did was incorrect, use it as a learning opportunity to figure out why. But anyway, let's graph these guys. Well, this graph's easy. That's just y equals x squared. I don't know exactly what that looks like, so I'll save that one for last. This one I need to focus on a little bit more. I don't want to reteach all of college algebra. But on the flip side of that, being in calculus 2, you're expected to remember almost everything you've ever seen in a math class, even if you haven't seen it in a while. So I'm going to kind of compromise and say, you might have forgotten what I'm about to show you, but I'm about to remind you, so stop forgetting it. I can find this graph pretty easily because I can note this equation for tons of information. Number one, it's a parabola because it's a degree 2 polynomial. Number two, the parabola is upside down because of the negative leading coefficient. But I can do even better than that. I can find its vertex and I can find its intercepts. In case you forgot, the vertex of y equals ax squared plus bx plus c, in fact, let's call this f of x because I'm going to be using that function in just a second. The vertex of f of x equals ax squared plus bx plus c is an ordered pair whose x coordinate is negative b over 2a. This is the formula from college algebra. And whose y coordinate can be obtained by substituting its x coordinate into the function. So f of negative b over 2a. So I'm going to use that tidbit of information to locate the vertex of this parabola. So in this case, we have a is equal to negative 1 and b is equal to 2. A is the coefficient of the quadratic term. B is the coefficient of the linear term, excuse me. And now I can just figure out this x coordinate by setting up x equals negative b over 2a. So negative 2 over 2 times negative 1. Well, that's just negative 2 over negative 2, which is equal to 1. So our vertex is at x equals 1. And to find the y coordinate, I just have to stick that 1 into the function. Now, I didn't call this a function, but let's just go ahead and call it f of x equals so that I can say y equals f of 1. If I put 1 in there, I get negative 1 squared plus 2 times 1. I want you to look at this for a second. Tell me what you think it equals. I know I can't hear you. It's like one of those goofy Facebook memes. Only geniuses can do this easy math problem. But the reason I asked is because if you're not careful, you're going to say 3 when you shouldn't say 3. Did you get 3? Then you didn't do negative 1 squared correctly. This is a very common mistake people make, even the best of mathematicians. They see something like this, and they think it says negative 1 squared. In other words, they think it says that when it doesn't. What this says is the opposite of 1 squared. Well, think of it this way. If I ask you what this equals, you're probably going to say 4, because you'll say 1 squared is 1, 5 minus 1 is 4. But none of you would say 6, because you know the square isn't on that negative. Well, guess what? It's still not on the negative. But when people see this, they tend to think it is. This means the opposite of 1 squared. 1 squared is 1, and the opposite of that is negative 1. So this is negative 1 plus 2, which is 1. Which means that this parabola has a vertex at 1, 1. Okay, so that's good information to know. But let's go ahead and find the x-intercepts as well, and that will be sufficient information to sketch this graph. Just a reminder, if you're an x-intercept, then you are a point where the graph crosses the x-axis, and if you are a point on the x-axis, you did not move up or down because your y-coordinate is 0. Which means to find the x-intercepts, you simply let y equal 0 and solve. And please don't get out the quadratic formula for this. It would work, but this will factor quicker. If we factor out an x, we get negative x plus 2. And anytime you have a product equal to 0, you can just set each factor equal to 0. And get x equal, well, this already says x equals 0, so there's nothing to do there. And if we add x to the other side, we get x equals 2. So now I know where the x-intercepts are. The x-intercepts are at 0, 0 and 2, 0. Remember, they're an x-intercept, they're on the x-axis, which means their y-coordinates are 0. These are just the x-coordinates. So now I've got all kinds of information about this graph. I know where its vertex is, I know where its x-intercepts are. I don't need a lot of room to find this. It just kind of lives in the corner of quadrant 1. So we're going to draw this a little bit larger than normal. Y equals 1, put it there. We'll go over 2 here. We know our vertex is at 1, 1, and our x-intercepts are here, and it confirms the fact that we have an upside-down parabola. Well, we have a parabola opening down. Who's to say that this one's not right side up? All right, so there is the graph of f of x equals negative x squared plus 2x. And the other one, which we'll call g of x, equals x squared. It's just a standard parabola whose vertex is at the origin and opens upwards. So here's g of x equals x squared. So do you see the bounded lamina right here? So which one's on top? It's actually the upside down parabola. On that little bitty lamina, the upside down parabola is on the top. And the standard parabola is on the bottom. So you have to make that recognition of who's on the top and who's on the bottom. Now the only other thing we don't know is the interval over which we're integrating. And you might look at this and think, well, it's obviously from 0 to 1. And although it actually is from 0 to 1, it won't always be obvious, so we need a better technique for finding where to integrate over. Well, think about it. We need to integrate where these intersect. Well, when these intersect, their y-coordinates are equal, which means their functions have to be equal. So, when you have an unknown interval, to find the interval over which to integrate, if it's not given to you, solve f of x equals g of x. And that will tell you the inputs that produce equal outputs, which is equivalent to saying finding the intersection points. So technically speaking, we have to solve negative x squared plus 2x, remember I already called this one f, equals g of x, which was x squared. And this is a quadratic equation, and we can solve it by getting equal to 0. I'm going to subtract x squared from both sides. Personally, I prefer to keep my x squareds positive, but I can handle negatives just as easily. Negative x squared and negative x squared is negative 2x squared plus 2x, and I can factor a 2 and an x out of this. And when I do, I'll be left with negative x plus 2. No. Negative x plus 1. If you giggle when I make a mistake, I watch much higher math videos than you might, and even those guys make casual mistakes. I saw one guy casually say that I think it was 1 times 2 is 4. Then he caught the mistake and fixed it. But my point is, I don't care how good you are at math, you make mistakes and it's okay, as long as you learn from them. 2x divided by 2x is 1. All right, so set each factor equal to 0. We get 2x equals 0, negative x plus 1 equals 0. But this solves to give x equals 0 and x equals 1. So the algebra confirms what our picture looked like it confirmed. And I said look like because hand-drawn graphs are rarely drawn to scale. There are technologies such as Desmos that can tell you the location of the intersection points. But this lamina is over the interval 0 to 1. So now we've got all the information we need to set up our integral. We know which one is greater than the other. We know which one is on the top versus the bottom. Careful, the top is the negative x squared plus 2x, and the bottom is x squared. And we know the interval over which we're integrating. And so now all we have to do is to set up and evaluate that integral. It will be, to find that area, is the integral from 0 to 1 of the top. And the function for the top is negative x squared plus 2x. Minus the bottom, and the equation in the bottom one is g of x equals x squared. Didn't really need those parentheses. Dx. I like putting parentheses around the entire integrand when it's more than one term. It's nitpicky, but it's what I do. All right, so this is the integral from 0 to 1. Negative x squared minus x squared is negative 2x squared, and then plus 2x. Wait a second, that was the thing we just solved to find the X intercepts, which actually makes sense because we put the functions equal to each other, and then to solve we had to subtract one from the other anyway. So that's nice. All right, so let's integrate this thing. Add 1 to the power to get x cubed, divide the coefficient by that new power, negative 2/3 x cubed, plus add 1 to this power to get x squared, divide this coefficient by the new power, but 2 divided by 2 is 1, so it's just x squared. From 0 to 1, and in this case the 0 is ignorable because it annihilates the antiderivative, but to be consistent I am going to substitute everything. Negative 2/3 times 1 cubed plus 1 squared minus negative 2/3 times 0 cubed plus 0 squared. Again, sometimes a lower limit of 0 does this and you can ignore it, but not always. Safest thing to do is to write it, because again, if something goes wrong but you write this, you're showing me you know something, I can give you partial credit. Negative 2/3 times 1 is negative 2/3. I'm sorry, 1 cubed is 1 times negative 2/3 is negative 2/3. Plus 1 squared is 1, and negative 2/3 plus 1 is 1/3. Not much of an area, but then again, it was a pretty small lamina. In fact, if you think about it, it had to be less than 1 because that lamina is contained inside of this unit square, and the area of that square is 1. So this is actually 1/3 of the area of that square. Not that that mattered, I just thought I would point that out.